Let's begin. We have limit as x approaches infinity of x plus 1 over x squared plus 3. The way we're going to be solving these limits is by finding the highest term on the bottom of the denominator. So in this case, x squared is the highest term. So I'm going to be multiplying everything by 1 over x squared, which is essentially dividing by x squared. So I'm going to have limit as x approaches infinity. Now this 1 over x squared is going to distribute to both the x and the 1. So it'll be 1 over x plus 1 over x squared. And on the bottom, it's also going to distribute. So the x squares will cancel, and we'll have 3 over x squared. Now we know that 1 over x and 1 over x squared and 3 over x squared will all go to 0. So we're left with 0 over 1, which is 0. So our limit is 0. Okay. Let's try a similar one. We have limit as x approaches infinity of 3x plus 7 over x squared minus 2. First, we identify the highest degree exponent, or term, of the denominator. In this case, it's x squared. So I'm going to divide by x squared, which is the same thing as multiplying everything by 1 over x squared. I have limit as x approaches infinity. Now the 1 over x squared is going to distribute to both the 3x and the 7. So I'm going to be left with 3x plus 7 over x squared all over. Well, the x squares will cancel. It's 1. And then we'll have 2 over x squared. So 3 over x, 7 over x squared, and 2 over x squared will all go to 0. So I'm left with 0 over 1, and my limit is 0. Okay. Now what happens if the degree of the numerator and the degree of the denominator are the same? We have limit as x approaches infinity. You have 7x cubed over x cubed minus 3x squared plus 6x. The highest degree of the denominator is the x cubed, right? So I'm going to multiply top and bottom by 1 over x cubed. So I'm going to have limit as x approaches infinity. The x cubes are going to cancel at the top, so I'm going to be left with 7. And now the x cubed times 1 over x cubed, that cancels. I'm left with 1 minus 3x squared over x cubed is 3 over x. And then 6x over x cubed is 6 over x squared. Now, 3 over x and 6 over x squared both go to 0. So I'm left with 7 as my limit. Let's try one with a higher exponent, but both the numerator and the denominator have the same exponent. I have 9x to the 4th plus x over 2x to the 4th plus 5x squared minus x plus 6. I look at the denominator and I see that 2x to the 4th is the highest term. Right. So that means I'm going to multiply the numerator and the denominator by 1 over x to the 4th. I'm left with limit as x approaches infinity. Now the 9x to the 4th and the 1 over x to the 4th, the x to the 4th will cancel. I'll be left with 9. And x over x to the 4th is just 1 over x cubed. On the bottom, the x to the 4th will cancel, so I'll have 2. Then we'll have 5x squared over x to the fourth, which is just 5 over x squared, minus x over x to the fourth is 1 over x cubed. And finally, we'll have 6 over x to the fourth. 1 over x cubed, 5 over x squared, 1 over x cubed, and 6 over x to the fourth will all go to 0. So I'm left with 9 over 2 as my limit. Okay. Next problem, I want to look at what happens when the denominator has a higher degree than the numerator. So I'm going to have 10x to the fifth plus x to the fourth plus 31 over x to the sixth. In this case, I can think of this as a fraction, as adding 3 different fractions. So I want to undo this addition. And I'm looking at the denominator here is x to the sixth. So I can place every term in the numerator over the denominator. So this is what we're going to have. And then if you wanted to add this, you would go back to the top. Okay, so next step, I want to simplify this. The x to the fifth over x to the sixth will just be x on the bottom, and then x to the fourth over x to the sixth will just be 1 over x squared, and then we'll leave 31 over x to the sixth the same. And notice that all of these will go to 0. So my limit is 0. Okay. Next, I want to be looking at what happens if the numerator has a higher degree than the denominator. I have limit as x approaches infinity of x cubed plus 7x squared minus 2 over x squared minus x minus 1. Here, I'm still going to be looking at the highest term in the denominator, which again happens to be x squared. So I can multiply everything by 1 over x squared. So I have limit as x approaches infinity. Now the x cubed and the 1 over x squared will turn into just x. And then 7x squared and 1 over x squared will be 7, since the x squareds will cancel. And then we'll have the negative 2 with over x squared. On the bottom, x squared times 1 over x squared will just be 1. And then negative x times 1 over x squared is 1 over x. And then finally, we'll have 1 over x squared. Notice 2 over x squared goes to 0. 1 over x goes to 0. And 1 over x squared also goes to 0. Okay, so we're left with the limit as x approaches infinity of x plus 7. We know x plus 7 is just a line. So it's a line like this. Oops. And as x approaches infinity, so as we go this direction, our y value goes to infinity as well. So this limit as x approaches infinity will just be infinity. So as we can see that if the degree of the numerator is higher than the degree of the exponent, we expect the limit to go to infinity. So let's try another one where that's the case. I have limit as x approaches infinity of 3x to the 7th plus 5x squared minus 1 over 6x cubed minus 7x plus 3. The highest degree on the denominator is 6x cubed. So I'm going to multiply the top and the bottom by 1 over x cubed. So I'm going to distribute the 1 over x cubed. So it'll be 3x to the 7th times 1 over x cubed will just be, that will just be 3x to the 4th. And then 5x squared over x cubed will be 5 over x. And then negative 1 over x cubed. All over 6x cubed and 1 over x cubed. The x cubes will cancel. And then negative 7x over x cubed will be negative 7 over x squared. And last one, we'll just have 3 over x cubed. We see that 5 over x, negative 1 over x cubed, 7 over x squared, 3 over x cubed, these will all go to 0. So I can rewrite this limit now as limit x approaches infinity, 3x to the 4th over 6, and that goes to infinity.